Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
My contributions to science stood out for one reason, namely, I worked alone. For that reason, I won the top prize in supercomputing alone and won it back in 1989 and at age 35. At that time, supercomputing was multidisciplinary. Supercomputing was a subject that drew heavily from mathematics, physics, and computer science. Therefore, it was typical for a team of 50 seasoned research scientists from different fields to cooperatively work together to solve a grand challenge initial boundary value problem of mathematical physics, such as developing the extreme scaled and the parallel processed general circulation model or the petroleum reservoir simulator. In a supercomputing research team, each scientist drew upon his or her disciplinary knowledge from his or her sub-specialties within physics, mathematics, and computer science, and with the team integrating its scientific knowledge and its mathematical techniques from those sub-disciplines. Some made the egregious mistake of comparing my contributions to the development of the supercomputer that won the top prize in supercomputing and did so back in 1989 to the contributions of a team of 50 supercomputer scientists that recently won the top prize in supercomputing. It's like comparing a 50-person relay race that covered a total distance of 50 miles to a one-person race that covered the same distance of 50 miles. But more importantly, the recent contributions of the team of 50 supercomputer scientists was to reconfirm for the millionth time my primordial discovery of practical parallel supercomputing that occurred on the 4th of July, 1989. Today, and in China, or United States, or Japan, or the European Union, a multidisciplinary team of 1,000 supercomputer scientists might be given a massively parallel supercomputer that costs up to $1.25 billion. The fastest supercomputer in the world costs more than the spacecraft that took men to the moon, and costs more than the budget of each of the 40 poorest nations in the world. The fastest supercomputer in the world is knowledge intensive and for that reason cannot be within the confines of any academic institutions, in part because the fastest supercomputer costs more than the annual budget of any institution of higher education. But more importantly, the body of knowledge of parallel supercomputing is extraordinarily deep and too expansive to reside in its entirety within any single academic institution. When parallel processing meets the biggest questions in computational science, the impossible to solve becomes possible to solve. Parallel processing is the vital technology that enables us to ask the biggest questions and then find new answers to those previously unanswered questions. I began my quest for practical parallel supercomputing in the realm of science fiction, namely by imagining the one binary million email wires that I must use to ingest my data and do so from outside a new internet that is a new global network of commodity off-the-shelf processors. I began that quest by imagining how to move my data efficiently and move them inside my 64 binary 1000 processors that were tightly coupled to each other and that shared nothing between each other. I also imagined my email messages as sent to and received from 2 raised to power 64 processors that I imagined as encircling a globe in 64-dimensional hyperspace. I discovered that our post-human descendants of year million will find it impossible to construct their parallel supercomputer that has a one processor to one vertex correspondence with the 2 raised to power 64 vertices of the cube in 64-dimensional hyperspace.
Insightful and brilliant lecture.